Hello everyone, let's discuss about fat for sport and exercise. First, let's learn about dietary fatty acids. There are three major dietary lipids: triglyceride, which are also known as true fats or neutral fats. It is stored in the human body. Next, cholesterol are also known as sterols, which is not a fat, but it is a fat-like pearly substance found in animals' tissues. They can be found only in animal products. We also have phospholipids. The most common phospholipid is lecithin. Egg yolks provide substantial amounts of lecithin. Other than that, our body can make all of the phospholipids it needs. Fatty acids are one of the main components of fat, and there are two types, which are saturated, which is solid at room temperature, for example butter. Unsaturated can be divided into two, namely monounsaturated and polyunsaturated. This is liquid at room temperature, such as oil. Moreover, omega-3 and omega-6 fatty acids are the two major types of polyunsaturated. Now, let's talk about common foods with fat content. For high fat content, generally could be any animal's foods found in the meat and milk groups. To be more specific, examples of obvious fat are butter, mayonnaise, and oils. Meanwhile, hidden fats such as cheese, potato chips, and in wide variety of commercial foods. For low fat content, lean cuts of poultry, any fish like tuna, except for salmon and mackerels, as they are high in fat and omega-3 fatty acid. Most plant foods are low fat except for nuts, seeds, and avocados. Omega-6 polyunsaturated fatty acids are found in vegetables and nut oils. Meanwhile, omega-3 polyunsaturated fatty acid can be found in green leafy vegetables, some nuts, and fish. Next, approximation amount of fat in daily diet. We need dietary fat for three reasons. Firstly, to meet the energy needs. Secondly, to provide essential fatty acid. Last but not least is to provide essential fat-soluble vitamins. Normal person are recommended to take about 25 to 30% of total energy intake, while active person can take up to 35%. So this is the recommendation based on RNI 2017. Saturated fatty acid should be taken less than 10%, while monounsaturated fatty acid intake are between 12% to 15%. Omega-6 polyunsaturated fatty acid intake are between 3 to 7%, while omega-3 polyunsaturated fatty acid should be taken between 0.3 to 1.2%. Cholesterol intake should not exceed a daily consumption of 300 mg. Now, major functions of dietary fat in human metabolism. For structure, it helps to form the structure of cell membrane, cover nerve fibers, as insulators to conserve body heat, and protect the organs through shock absorbers. For metabolic regulation, first, cholesterol is used by the liver to produce bile salts. Next, phospholipids are instrumental for blood clotting. Next, adipose cells produce adipokines that function as hormones, and lastly, involved in physiological functions. Let's move to the role of fat during exercise. During exercise, fat is one of the major energy sources to produce ATP in the form of fatty acid. 25% of FFA re-esterified during exercise, leading to increase in FFA transport to the muscle cell. Hormones that activate, such as epinephrine, secreted then stimulate the breakdown of adipose cell triglyceride and release FFA to the blood. Meanwhile, during rest, fat provides 60% of fat energy. The use of fat are different based on the type of exercise. To begin with, during mild exercise, 80% of the energy is from fat. FFA are provided at a higher rate and become the primary source of fat energy during this exercise. Next, muscle triglyceride increases as exercise intensity increases, about 65% of VO2 max. During moderate intensity, both fat and carbohydrate contribute equally to the energy expenditure and plasma FFA, and the muscle triglyceride also contribute equally to the energy derived from fat. However, for high-intensity exercise, the percentage of fat used decreased to 25% as the glycogen became the source of energy. FFA oxidation decreases due to the increase of carbohydrate oxidation. Now, let's discuss about how endurance exercise training affects exercise fat metabolism. Endurance exercise training increases the capacity of skeletal muscle for fat oxidation by increasing mitochondrial density, the activity of the enzyme involved in beta oxidation and oxygen delivery to the muscle. Next is increased sensitivity for both muscle and adipose cell to epinephrine. Other than that, it increased the activation of FFA and transport across the mitochondrial membrane. Lastly, endurance training will enhance muscle triglyceride is associated with increased insulin sensitivity that regulates FFA into the muscle cell. Next, ergogenic aspect. In ergogenic aspect, more acetyl-CoA will be produced due to increase of fatty acid availability and oxidation, resulting in less active carbohydrate degrading enzyme. Thus, muscle glycogen use can be spared and enhance endurance performance. The strategies include high-fat diets, fasting, and infusion of lipids into the bloodstream. Firstly is high-fat diet, a low glycemic index diet that may improve endurance performance through an elevation in fat metabolism. The diets include acute and chronic high-fat diets. The first strategy of acute high-fat diets is to infuse heparin and a lipid solution directly into the circulation to promote lipoprotein lipase activity and raise plasma FFA levels. Increased fat oxidation and decreased carbohydrate oxidation may improve the effectiveness of endurance exercise. Second strategy is to ingest a high-fat meal prior to exercise performance. Next is chronic high-fat diets. Some studies state that ergogenic effects may result from muscle glycogen sparing. Conversely, other research indicates that there are no ergogenic effects as it degrades high-intensity sprints performance. Fasting stimulates fat oxidation, glycogen spared, increases the availability of FA, and improves performance. However, fasting may have a negative impact on performance if muscle glycogen levels lower or hypoglycemia. Medium-chain triglycerides are ergogenic due to its water-soluble characteristic. Its advantage can be absorbed and delivered directly to the liver via the portal circulation and more easily enter the muscle cell's mitochondria. Exogenous MCTs are oxidized at a rate similar to that exogenous glucose. Lastly, let's talk about the dietary fat supplement. First, phospholipid dietary supplement, which divided into lecithin and phosphatidylserine. Lecithin, or known as phosphatidylcholine, is natural occurring phospholipid found in food, while phosphatidylserine is found in cell membrane. Several studies have shown that lecithin supplementation is able to significantly increase plasma choline levels during strenuous exercise has been reported to result in decreased choline concentration within the blood. The chart shows the example of drop in plasma choline levels. Von Worden suggested that choline supplementation prior to exercise can prevent a decrease in choline levels from hard physical stress that could affect performance. Although the phosphatidylserine supplement have little effect on reducing markers or muscle soreness after severe exercise, Kingsley found it can increase running time to exhaustion, which might pose ergogenic potential. Several double-blind, placebo-controlled clinical trials have been performed to investigate whether phosphatidylserine supplementation prior to exercise can prevent the exercise-induced increase in cortisol levels and improve other markers related to heart training. Results shows the supplementation significantly suppresses ACTH and cortisol responses to exercise. In weight training, athletes had less muscle soreness when they were taking the supplement compared to the placebo. Next is omega-3 fatty acid and fish oil supplement. Omega-3 fatty acids, specifically EPA and DHA, are receiving increasing attention in sport nutrition. Several studies suggested a potentially beneficial effect of DHA and EPA on performance by improved endurance capacity, as well as markers related to enhanced recovery and immune modulation. Omega-3 fatty acid supplementation also has no effect on aerobic endurance performance. For fish oil supplement, it is mentioned can cause bleeding by reduced stickiness of the platelet. Other dietary fat supplements are hydroxy citrate and conjugated linoleic acid. These are all the references we use in this video. That's all from us. Thank you for watching.